Morning, dear students. In previous class, we learned about complex numbers, formulas, properties, and problems also. Especially, we learned the exponential form. So, today we will learn some more problems on complex numbers. So, recap. Exponential form of a complex number. We know that e power x equals to 1 plus x by 1 factorial plus x square by 2 factorial plus x power 3 by 3 factorial plus up to so on. Put x equals to I theta. We have e power I theta equals to 1 plus I theta by 1 factorial plus I theta whole power 2 by 2 factorial plus I theta whole power 3 by 3 factorial plus dash 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 dash, that equals to 1 plus 1 minus, see here we are writing real parts first and then we are writing imaginary parts. So in the series the third term is real part because I square means minus 1, so minus theta square by 2 factorial like that, and fifth term also. So real parts should be put together and imaginary parts are also separate. So like this, theta power 4 by 4 factorial minus dash 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 plus I of 6 minus 6 power 3 by 3 factorial plus 6 power 5 by 5 factorial minus up to so on. Next, that equals to cos theta plus I sin theta. That implies x plus iy equals to r of cos theta plus I sin theta. That equals to r into e power I theta. Thus, exponential form of x plus iy is r into e power I theta. Objectives. On the completion of this period, you would be able to state De Moivre's theorem, state properties of De Moivre's theorem, solve problems using De Moivre's theorem. De Moivre's means it is a name of the scientist. So, introduction. The famous De Moivre's theorem is due to the French mathematician Abraham de Moivre. 1667 to 1734, he lived in that period. So he is related to 16th century, or we can say 17th century, who made important contributions to trigonometry, statistics, and probability. The theorem gives a powerful method of obtaining roots and powers of real and complex numbers. De Moivre's theorem statement: if n is an integer, positive or negative, then cos theta plus I sin theta whole power n equals to cos n theta plus I sin n theta. Second one, if n is a fraction, positive or negative, then one of the values of cos theta plus I sin theta whole power n equals to cos n theta plus I sin n theta. Remarks: cos theta plus I sin theta is sometimes written shortly as cis theta. So cis theta means cos theta plus I sin theta. Second point, just second point is sin theta plus I cos theta whole power n is not equals to sin n theta plus I cos n theta, but sin theta plus I cos theta whole power n equals to cos of pi by 2 minus theta plus I sin of pi by 2 minus theta whole power n. That equals to cos n into pi by 2 minus theta plus I sin n into pi by 2 minus theta. Third point, cos alpha plus I sin beta whole power n is not equals to cos n alpha plus I sin n beta. Corollaries: corollaries means from the theorem statement, if we get another proofs or another formulas, like another statements, from based on that theorem, if we get more proofs or more statements or more properties, then that theorems are called corollaries. So first one, cos theta plus I sin theta whole power minus n equals to cos of minus n theta plus I sin of minus n theta. Next, cos n theta minus I sin n theta. Next one, second one. Cos theta minus I sin theta whole power n equals to cos of minus theta plus I sin of minus theta whole power n. See here, the negative symbol of the imaginary part is taken inside of the sign, and cos theta and cos of minus theta is same. So now in the right side term, both are having same angle. Both are having same angle, that is minus theta minus theta. So cos of, now applying n whole power n is, that is cos of minus n theta plus I sin of minus n theta, and finally we can write cos n theta minus I sin n theta. Third point, cos theta minus I sin theta whole power minus n equals to, so cos of minus theta plus I sin theta, see here, plus I sin minus theta, minus is not printed, so we have to put whole power minus n, then cos of minus n theta minus of I sin of minus n theta, then cos n theta plus I sin n theta. See here, in the statement, based on first theorem, these are came. Next point, fourth, 1 by cos theta plus I sin theta equals to, you can write cos theta plus I sin theta whole power minus 1. So here in place of n we have minus 1, so that equals to cos theta minus I sin theta, that is minus 1 into theta, means in cos negative also we can write as a positive, so cos theta, and in the sign negative will come to the outside, so minus I sin theta. Next, fifth point, since cos n theta plus I sin n theta into cos n theta minus I sin n theta equals to 1, we have a cos n theta minus I sin n theta equals to 1 by cos n theta plus I sin n theta, that equals to cos n theta plus I sin n theta whole power minus 1. Next, b, cos n theta plus I sin n theta equals to 1 by cos n theta minus I sin n theta, that equals to cos n theta minus I sin n theta whole power minus 1. Euler's formula, e power I theta equals to cos theta plus I sin theta. E power minus it equals to I theta equals to cos theta minus I sin theta. e power I into n into theta equals to cos n theta plus I sin n theta. E power minus I n theta equals to cos n theta minus I sin n theta. Next, problem 1. Simplify cos 26 plus I sin 26 whole power 3 into cos 36 minus I sin 36 whole power minus 3 by cos 46 plus I sin 46 whole power minus 6 into cos 6 plus I sin 6 whole power 8. So here's 6 sorry, in place of 6 you have to note that theta it is, sorry. So in the, see, once again I am reading the problem. Cos 2 theta plus I sin 2 theta whole power 3 and into cos 3 theta, that is theta not 6. So the printing is like showing, but it is actually theta. So here 6 is showing, but it is a theta. So in the question, observe, so numerator and denominator are also, that is not 6, that is a theta. So once again I am reading the problem. Cos 2 theta plus I sin 2 theta whole power 2 into cos 3 theta minus I sin 3 theta whole power minus 3 by cos 4 theta plus I sin 4 theta whole power minus 6 into cos theta plus I sin theta whole power 8. So the question is asking that simplify. So by using De Movers theorem we can simplify, or we can show it is in the short form. So see the solution. Given expression is cos 2 theta plus I sin theta whole power 3 means here De Movers is applied. That means cos n theta. N means 3. So 3 into 2, 6. So cos 6 theta plus I sin 6 theta into cos, so here De Movers theorem is applied. That is cos 2 into 3 theta means cos 6 theta plus I sin 6 theta. Similarly, second factor also we can write cos 9 theta plus I sin 9 theta. By in the denominator also we are applying De Movers. So cos 24 theta minus I sin 24 theta and cos 8 theta plus I sin 8 theta. Next, that equals to again here we are converting it is as a whole power n, that is cos theta plus I sin theta whole power 6. So here in place of n 6 is there, and similarly second factor also in the numerator, cos theta plus I sin theta whole power 9. Similarly in the denominator also, cos theta plus I sin theta whole power minus 24, and cos theta plus I sin theta whole power 8. That equals to cos theta plus I sin theta whole power 6 into cos theta plus I sin theta whole power 9 by cos theta plus I sin theta whole power minus 24 into cos theta plus I sin theta whole power 8. Next, numerators are same, sorry, yeah, in the numerators the factors are same and powers are different. So write one term and add the powers. That means write the base 1 because bases are same, and if they have multiply means product means we can add the powers. A power m into a power n equals to a power m plus n. So that similarly here we are applying the numerator and denominator also. So cos theta plus I sin theta whole power minus 24 plus 8. Here also we are applying a power m into a power n formula. So bases are same and powers are different, then we can, that product can be written as a one base and power should be added. So similarly here we are applied that formula, so minus 24 plus 8, and again another formula here we are using a power m by a power n means a power m minus n. So bases are same, and if that powers are different and it is divide, so we can write as a one term, base is 1 and power should be subtracted. So simply we can say a power m by a power n equals to a power m minus n. So cos theta plus I sin theta whole power 13 minus 16. Minus 16 if it comes to the numerator's power, so it is minus of minus plus. So 13 plus 16, sorry, 15 plus 16, that is not 13, 6 plus 9 is 15, so 15 plus 16, that equals to cos theta plus I sin theta whole power 31. That equals to cos 31 theta plus I sin 31 theta. So this is, we are simplified from 4 terms to 1 term, or 4 factors to 1 factor, like that. So from big term to short term. Okay. Second problem or second question. Simplify cos 4 theta minus I sin 4 theta whole power 3 by sin 2 theta plus I cos 2 theta whole power 5. The solution is, Here also asking simplify, that means we have to bring in the short form or single term. So here numerator and denominators are there, so we have to only one term, so denominator should be, we have to vanish. So see how to do, very simple, as it is like above question. So take the given expression or write the given expression. Cos 4 theta plus I sin 4 theta whole power minus 1 again whole power 3. And because we are written the minus is in the imaginary part, we have in bracket minus, so if we want plus before imaginary part, then we have to send that minus to power. So we already know the demores, that is cos n theta minus I sin n theta can be written as cos theta plus I sin theta whole power minus n. So here n means 1, so whole power minus 1, again already we have power 3, so minus 1 again whole power 3, that is minus 1 into 3 minus 3. In the next step you can observe, and here in the denominator taking I power 5 common, then it is written as cos 2 theta plus 1 by I power 5 sin 2 theta, and again whole power 5. Sorry, don't take I power 5, I take the common, already power 5 is there, so if I is taken common from in the denominator bracketed terms, then it becomes I power 5. So if I is taken common, then it is becomes I power 5 because whole power 5 is there, so that's why. And in the bracket we can write cos theta because already I took common, and in sin theta it is not a I, so we have to write 1 by I into sin 2 theta. Next 1 by I can be written as minus I, so cos 2 theta minus I sin 2 theta whole power 3. Next step, apply the power minus 3 as a De Moivre's theorem. So cos minus 3 into 4 means minus 12. So cos minus 12 theta plus I sin of minus 12 theta by, here I power 5 means I. So cos 2 theta minus I sin 2 theta whole power 5 means, here also if we apply, it is cos 10 theta minus I sin 10 theta. And see this step. Again we can, it is write as a cos theta plus I sin theta whole power minus 12, because from De Moivre's we can write left to right and right to left. So here assume minus 12 is n, then cos n theta plus I sin n theta means cos theta plus I sin theta whole power n. So from that we are written here minus 12 whole power minus 12. And similarly in the denominator also, I is already outside, so I into cos theta plus I sin theta whole power minus 10. Here bases are same, powers are different, and they are in the form of fraction. So write one base and subtract the powers. So 1 by I is common, and cos theta plus I sin theta whole power minus 12 plus 10. Then it becomes minus 2. So 1 by I into cos of minus 2 theta plus I sin of minus 2 theta. Again here applied the Movers. Next 1 by I into cos 2 theta minus I sin 2 theta. Sin of minus 2 theta means minus sin 2 theta. So minus is kept before I. Then 1 by I means minus. So if you multiply with see here, here 1 by I is multiplied bracketed terms, then it becomes I get cancelled, so minus sine 2 theta, and in the cos there is no I term, so we can write minus I square, because I square means minus 1, minus into minus plus, so that minus I square. So if you multiply it with 1 by I means I get cancelled, so minus I cos 2 theta. So this is the simplification of the given expression. Next, summary. We have discussed about statement of De Movers theorem, properties of De Movers theorem, problems using De Movers theorem, and quiz. See the quiz. First question. Cos theta minus I sin theta whole power n is equals to, very simple question. It is the De Movers theorem. So ABC, from ABC answer is B. So B is the answer, that is cos n theta minus I sin n theta. Very simple question. Next, second question. E power minus I n theta is equals to, so A, B, C are given. So answer is A, cos n theta minus I sin n theta. Next, assignment. Simplify the following questions. That is, two questions are there. First one, cos theta plus I sin theta whole power 8. Here brackets are not printed, so keep them in bracket, into sin theta plus I cos theta whole power 4. So this should be kept in a bracket. In the denominator, cos theta minus I sin theta whole power 3. So now see the second question. Cos phi theta minus I sin phi theta whole square. Here also brackets not printed, so we have to kept. Cos 7 theta plus I sin 7 theta whole power minus 3 by cos 4 theta minus I sin 4 theta whole power 9 into cos theta plus I sin theta whole power 5. So these assignment problems are available in your textbook, exercise problems or example problems. So you need not worry about brackets, because sometimes in the system, in mathematical especially, there is a so much time takes to enter the symbols, and sometimes the system may not accept, sometimes it is appears, sometimes it is disappears. We don't know how that is working. So don't worry, these questions, the printing is not printed properly. By observing, we can easily say, oh, power 2 means the bracket is missing here. To in the base, the bracket should be there. So till you have any doubt, you can open the textbook and you can see the questions. So don't worry about some printing mistake in the questions. So do this assignment, and not only this assignment, you have to do the problems from textbook exercise questions also, and see the example problems. Some example problems we are covered in this PPT, and some more problems are also maybe in the textbook. So here simplifying means very easy questions are asking, because if you remember the one theorem, De Movers, or one statement, then you can easily simplify the whatever he gives. How much big expression is given, we can convert it into short form by using De Movers theorem statement. And we have to know 2-3 properties, like a power m into a power n equals to a power m plus n, and another property is here a power m by a power n equals to a power m minus n. And one more thing is, in the question, whatever it may be given, we have to convert into the basis of the numerator and denominators should be same. Then we can easily simplify the given question or expression or problem. So first of all, apply the De Movers theorem from left to right or right to left. It is our convenient. And after that, to simplify, to apply the algebraic expressions or properties, basis should be same. In between, the product is or multiplying means, if bases are same, we can easily convert it into the short form, that is one base and power should be added if both are in the numerator. If in the fraction, the powers should be subtracted from numerator. From numerator, the denominator is subtracted. So simple formula is a power m by a power n equals to a power m minus n if the divider is there. if multiply is there, then we can write a power m into a power n equals to a power m plus n. So if you remember these three things, first one is de Moivre's statement, that is cos theta plus I sin theta all power n means cos n theta plus I sin n theta. If power is minus n, then it becomes cos n theta minus I sin n theta. Very simple. And after converting bases are same, then you have to apply this formula, a power m into a power n equals to a power m plus n. And if the expression is in the form of a power m by a power n, then we can write a power m minus n. Already these formulas you know, but still I will remembering you. So only these three rules, if you remember, you can easily simplify the questions or problems. So very easy. I hope you will understand the concept, and if you have any doubts, ask me or mail me. And I am once again advising you is open the PPT first, see the PPT and take the notes, and then listen the video. Then you will be easily understand. In the video sometimes screen clarity may miss, but if you are having PPT means you can overcome that issue. Till you have any doubt, you can ask me or you can ask your friends if they are understand of your doubt, if they know your doubt, and if you know your friend's doubt, you can clarify his doubt so that you may get more commanding on problems, formulas, concept, and write in the rough notes and fair it in the fair notes. In the fair notes, maintain the order. After first question completion, then only come to second question. If first one is not completed, so don't write in the fair notes second question, because order is important, neatness is important, and if any question is not solving by you, then you can ask me. I will clear your doubt and I will tell you once again, and I will send you the solution also. So I hope you can easily do the complex numbers problems. So in the textbook, whatever the questions are given in exercise, you start it and complete it and write in the fair notes also. So I will check the fair notes each and every student. So don't pending. Do the sums or problems every day. Okay. Have a nice day. Thank you.